usually when we do these, we're in person, and I would ask what it's like to be back on campus. But obviously, we're not in person, so what's it like to not be on campus?
Well, it's good. It's good for me. I've left campus in March 2020. I've been back to collect stuff from my office, and since then I've moved about 3 times. So it's nice, but obviously it's a different way of working.
Yeah, I can totally relate to that. I think it's been a new experience for everyone. Could you maybe tell us about your current job then and how you got there since graduating?
Right. So I currently work for British Antarctic Survey, and I'm an ice fracture modeler. I work on trying to understand the processes in the Antarctic and Greenland ice sheets and ice shelves that contribute to sea level rise. I finished my bachelor's in maths in 2016 in Heriot-Watt. I then started my PhD in mathematics at the Maxwell Institute Graduate School for Analysis and Applications, which is a joint venture between Heriot-Watt and University of Edinburgh. I defended my thesis in 2020, and from September 2020 I work for British Antarctic Survey. Part of this big consortium of researchers called Protect Sea Level Rise that are trying to narrow down the uncertainty margins on different climate change scenarios that come from melting ice. So the IPCC has recently published its new report, and there are different scenarios of how much CO2 emissions we allow for and such. But the crucial bit is that we don't actually understand what's happening to this big chunk of ice that's all around the globe somewhere.
That sounds like a really important research area for something that is seemingly so common. In retrospect, what was the most useful thing you learned during your degree? That could be maths or non-maths.
I guess that it's important to develop your own routine that suits you and others around you. Obviously, you have other commitments, you have other things to do, but everybody has a wonderful chance of trying basically what works for them and what doesn't. Experimenting with this is definitely rather useful during an undergraduate degree. And the second thing that I've definitely learned is that if you need help, then ask for it. There are people that will help. And I guess that otherwise, more maths related is that if you are looking for a job, the job title will very rarely say a mathematician. You should look around quite widely and look for basically any company if you are interested in it. They are just hiding in plain sight. There is a really broad range of things that you can do with maths. It's just you are told what you can do in primary and secondary school with maths, and then in university they tell you something more, and eventually you realize more and more what you can actually do.
Yeah, I definitely agree with that. I think we're all discovering lots of little things that we could apply maths to in our daily lives. Was there maybe anything else that you like to mention about your time at Heriot-Watt?
Make use of library resources. The library is there. They have amazing stuff. They have plenty of resources. Just make use of it. And when you are learning new maths, try to see where it fits in the grand scheme of things. That's not very much towards Heriot-Watt, but in general, towards what I've learned in my degree.
What kind of maths enters into the work you do now? And how does it enter?
Right. I use maths on a daily basis. So I develop mathematical models that do help us understand if we will have Antarctica in the shape that we know it at all, really, in 100 years or in 200 years. And so the crucial question is, why do we need a big, complicated model to understand a giant block of ice? The answer is kind of convoluted. At big scales, ice is really an extremely thick fluid. In certain places near the center of the ice sheet, it moves really slowly. It moves at maybe 10 meters per year. And along the coast, it moves more like thousands of meters per year. The interior of the ice is thicker and the surface is higher. Therefore, you have cooler weather. And at the coast, the temperature is warmer, and there the ice also comes into contact with relatively warm ocean water. The question is how much will melt or break off. And so you need to know how quickly it moves, how it breaks. And for this, you need a fairly big computer and fairly big computer simulation. However, there are a lot of uncertainties, so you don't know what happens at the coast, how exactly it will interact with the seawater, what happens if it hits some obstacle, some piece of rock, and where will the ice actually go? So my job is to understand what happens and how it happens. I use a simplified version of Navier-Stokes equations, which you can see in the applied courses in Heriot-Watt. I then modify it and include some other things. I make sure that the problem makes sense in some way, which then you use a lot of analysis courses that you see in Heriot-Watt. And then I write computer codes and simulations and make sure that the simulations actually converge to the correct solution. So I use everything that's in Heriot-Watt, produced at Heriot-Watt and offered at Heriot-Watt in your undergrad degree on a daily basis, basically.
Oh yeah, that's really good to know. Did you always know that you wanted to go into this area or work on these problems specifically?
No. So I've learned about British Antarctic Survey maybe 10, 12 years ago. I knew at some point that I wanted to do something with maths. So I went and did my undergrad. Then it made sense to go into a PhD. And then last year I was looking for a job, and British Antarctic Survey was always kind of floating at the back of my mind, and I found a job with them. So I didn't know that I wanted to do precisely this, but something with mathematics was always an option for a long time.
Was your PhD related to polar research at all?
I did a PhD in numerical analysis, but in a lot of ways it had nothing to do with ice. You could potentially make some parallels, but no, it didn't. I was thrown into the deep end when I started the job. I knew very little about ice and how ice moves and what all terminology is, and then within a few months I knew what it was because I had to learn it rather quickly.
Yeah, I think this is a common experience for many of us at the beginning. Do your colleagues have the same background as you? Are they all mathematicians?
No, definitely not. People come to polar science from all possible backgrounds. So there are glaciologists, there are climate scientists, biologists, chemists, ecologists, engineers, physicists, mathematicians, and the list goes on. It's a big intertwined thing that you need a lot of different people to come together and really tell you something about ice caps and our ice sheets.
That sounds like a really good working environment. Why do you think a new graduate should really join this area?
To put it simply, because there is a lot of cool problems and important problems to solve. And because we always need new people who are interested in this. If somebody's interested, they are always welcome to contact me, and I can direct them in a possibly correct direction. Why is it interesting? Why is it relevant? Because, well, crucially because of climate change. The icy regions cover only a small part of the Earth. We have about 200,000 glaciers around the globe and two big ice sheets, one in Greenland, one in Antarctica. And if all of them started to melt, and all of them fully melted, the sea level would rise by about 65 meters, which would definitely impact how we live rather quickly. And so this is what we are currently trying to answer: how and what makes a huge effect, and how much will each of these glaciers and ice shelves contribute to the sea level rise. For example, under the current Paris Agreement that says that we are accepting kind of an increase in temperature of 1.5 degrees, the main projections say that the water would rise by 2100 by about 13 centimeters, the pessimistic projections by about 30 centimeters. And the big chunk of it is coming obviously from Antarctica, some part from Greenland, and basically all of our glaciers would melt. If we don't want this to happen too quickly, we should probably act, and we need more people.
I think we understand the challenges your field is facing, but could you maybe tell us a bit about any challenges you personally faced since leaving university?
Right, so when I left my undergraduate, obviously a big challenge was to do my PhD. Since roughly finishing my PhD, obviously COVID struck all of us. But in general, for me, probably kind of trying to establish some work-life balance myself, that's always been an issue, and trying not to overdo it with work. Going into a new research area is definitely a challenge, but in some respects, because you are new in that area, you have a certain excuse for a wee while to ask silly questions. And everybody probably has some form of a worry, oh, I don't want to ask silly questions. And then people tell you there are not such thing as a silly question. That's probably true, but you can truly ask the silliest possible questions. What is this acronym that I absolutely don't know and should probably know if I am working on something for half a year? On one hand, it's slightly more difficult, but on the other hand, everybody somehow expects that you need some time to adjust. And this is a good mindset to go in a new workplace with this sort of mindset. Okay, I am new here. I need to learn new stuff, but they are kind of expecting it. So I can ask my silly questions.
As a final question, do you have any words of wisdom for our students?
Find a thing that makes you happy and gives you fulfillment. If you think that something's interesting or sounds interesting, try it, go for it. Maths crops up in a lot of unexpected places. So if you want to do mathematics, it's everywhere. It's all around in all possible different jobs, all different places. So go for what makes you happy.
So were there maybe any questions that we didn't ask you? Do you have anything else that you would like to say?
I think that you've asked me all the possible questions.
Well, then thank you for joining us.
Thank you.
And to our listeners, look in the description for some more info on the British Antarctic Survey and some undergraduate research placements. Thank you for listening, and I hope you enjoyed the newsletter. See you soon.